Hello，今年你有听到吗？可以听到，可以，
啊，有，
可以开，你们开那个视频我解的。
可是天花板可以接收嘛？
还有谁顺利诶？顺利不要去调你的吉他，快来，给了，不用紧了，给了，够了。我 record 那一哦，对，可以开始了啊。调整一下，我讲要用英文。Good evening, everyone. Welcome to the class. Today our topic is function. Function. Okay, before we start, I'll briefly go through our learning outcome of this class. Okay. At the end of the class, you'll be able to express function using function notation, determine domain, object, image, range, and of a function. Okay. Determine image of a function given object, or vice versa. Vice versa mean we give you image and with you find object. Determine composition of two function. Determine image of composite function given the object. Determine one of the function in a given composite function given the other related function. Okay, this is our learning outcome. So before we start the class, I'll show you this video about function. Okay, just a quick video. Let's talk about juicers. If I have a juicer, and let's say I want to make punches. We'll make orange juice for it. My input would be that orange into the juicer, and my output is the juice that comes out of the juicer. Notice that if I were to put grapes into the juicer, I couldn't expect to get orange juice out of the juicer. I'd get grape juice. And if I put an apple in the juicer, I'll get apple juice. So for each type of fruit I put in the juicer, I'll get that same type of juice out. This is kind of like a function. f of x equals 2x plus 1 is a good example of a function. Then you can think of f of x as a machine and a like a juicer. But instead of putting fruit in this machine, we're going to put numbers. And for each number we put into this machine, we can expect to get one number out of it. So for instance, if I take the number 3 and I put it in this function, this machine, I can expect to get one number out. And that number we can get by plugging in 3 into our function. What we mean by that? F of 3 is going to be 2 times, so we have an x here, we're going to replace it with a 3. So we have 2 times 3 plus 1. And that equals 6 plus 1, which is 7. So when I put 3 into this function, I can expect to get 7 out of it. Anytime I put 3 into this function, I'll get 7 out. In fact, for any number that I put into this function, there's only one number that will come out of the function. That's the definition of a function.
Okay.
Here's one more example of a function.
Okay. After the video, these two photos they are from your textbook, your NMAX textbook. So from these two photos, from these two texts, what can you say about this? You are working as a temporary cashier and is paid 80 ringgit daily. The total payment received is determined by the number of days you work. So if we want to write the payment you receive, okay, what will you write? Payment equals to 80 x. A given x is number of days you work. Okay. How about this? You are buying durian from a store. If the cost of 1 kilogram of durian is 8, total amount you need to pay depends on the weight durian you bought. Okay, so okay, cost equal to 8x. Okay. X is durian. Okay, weight, mass of durian in kg. Okay. Okay, I'll briefly go through because you are taught of the basic knowledge of function already. Okay, let's see. Okay, it's the same durian. Okay, for every kilogram durian sold, Ahmad gets 2 ringgit profit. Ahmad will also charge the buyer an extra 1 ringgit to extract the durian meat for every purchase. Okay, what can we get if you buy 1 kg, 3 kg, or 5 kg? Okay. Okay, from here we can know that the profit of Ahmad get is 2x plus 1. Okay, from here, x is kg, okay, durian in kg. Okay, 1 kg he will get, this x is 1, so 2, okay, he get, okay, 3 kg he get 7, 5, okay. If we ever want, we want to see, okay, 1 and 3, or in ordered pair. Okay, this is your ordered pair. And also here, okay, 1, 3, 3, 7, and 5, 11. And this is also the same representation. Okay, this is also the same. Okay, what we say about this function, this is a function. Element x, okay, here is x, here's y. Element x in set x, okay, this is set x, is mapped to element y Oh, this is in set y. Okay, next. Okay, domain, codomain, and range. Okay, from the same example, domain is this part. You learn it in Form 2 already. Okay, in range, okay, 3, 7. If we have another element here, 13, okay, what will your codomain and range be? Your codomain will be 3, 7, 11, and 13. Okay, and your range, since 13 is not mapped, since 13 is not mapped, so the range will still be the same. Okay. Can we find object with given image? So what is image from here? Okay. How many kilograms of durian Ahmad sold if a customer paid 51 ringgit? We know 51 ringgit is in here. So what is this? So we know that from the function, we define it as fx 2x plus 1. We know that our image is 51. So 51, 2x plus 1 equal to 51. Okay, and x is 25. Okay, we know that Ahmad sold 25 kg of durian. Okay, this is how you find object with given image. Okay, next I'll talk about composite function. Composite function. Okay, first we must know what is composite. Composite from Google Translate is made up of various parts or elements. Various parts or element. Okay. If a function is composite, meaning the function have multiple parts of function. Okay, this is the image that represent composite function, fx and gx. Okay, this mean this lah, gfx, and this is composite function. Okay, not this. Okay, this is not composite function. This is simply multiplication of functions. For composite function, in one function, there are multiple parts. Okay. Okay, it's the same durian problem. Okay. This is still the same from the normal function. This is the function. So is this composite function? So the answer is no. Okay. Because this is just a simple function. So I add another condition or business model for Ahmad. Ahmad decides to charge delivery service if customer could not collect the durian at 50 ringgit per purchase. Meaning every purchase customer made, if they want delivery service, Ahmad will always charge 50 ringgit. So the new function will be x plus 50. Okay, yes, this is a function, yes. So what is the composite function? Okay, if Daniel wants to buy durian and get a delivery service from Ahmad. So we know that fx is 2x plus 1. Gx is x plus 50. Okay, the composite function, since fx comes first, so fx must be written at behind. So it's equal to g of 2x plus 1. The fx, which is 2x plus 1, is written here. So the function g will then apply to this. This is your object in your second function. So 2x plus 1 will be your next object in your second function. So 2x plus 1 will be your x, which is the x in this x plus 50. And then you plus another 50, which is 2x plus 51. Okay. This is what Daniel need to pay if he want to buy durian from Ahmad. Okay, Daniel and Ahmad. If you want to buy durian from Ahmad and ask for delivery service, the X will be the how many kilogram of the durian he bought. Okay. This is our next slide. Okay. Can we find object with given image? It's the same as what we just now here. Okay. So what we want to find is using the composite function, this one. This one. Okay, because the question is Daniel paid 131 ringgit. So we know that GFX is equal to 131. So 2x plus 51. So we minus away the 51 from both sides. Okay. Okay. What will be this? 80. So divided by 2, x will be 40 kg. So Daniel bought 40 kg of durian and he paid 131. Okay, next. Okay, this is a very lengthy problem. Yeah, let you guys try. Yeah. Okay, Damien is another name. Okay, this now is Daniel, a different person, right? Damien started his durian business, another durian business, and he copied Ahmad's business model. Okay, what is Ahmad's business model? Fx is 2x plus 1. Gx is x plus 50. So, but in this case, he used different function. The composite function is given already. The composite function of his durian business is given to be this. Okay. Gfx is equal to 4x plus 20. Okay. Delivery, he charged 15 ringgit. So what is the function of the durian business? If a customer, they decided to not use the delivery service. Okay, what is this question asking? Customer decide not to use delivery service, which means GX must be removed from this composite function. So how do we remove it, or how do we split them up? So you know that GX gx is x plus 15, okay, because of the delivery. So how do we get fx? Yeah. Okay. So we want to find fx. Okay, how about we look? I'll write this differently. G fx is equal to g function g. I'll write another parenthesis like this. So fx will be the object of this function g. So what is g? What is g? What is function g? X plus 15. So we know that fx is our object. So fx will be replacing this x because x is also object of g. So fx plus 15 is this 4x plus 10. So minus away this, and then this will be left 5. So fx is 4x plus 5. This is how you find another function from a complete function. Oh. Okay. Okay, let's try some exercises. I think there will be 4 questions. Yes, 4 questions. Okay. How about we take 5 minutes, okay, for this question? Okay, this is fx and this is gx. Okay. Okay. Everyone try this question, A to G. You know. This is very simple question, so I think 5 minutes should be enough. We need to look at these two. These two are different, gfx and fgx. Okay. We always look at the first that's closest to the object. So this is A and this is f gx. Okay, it's same as this image, but this is gfx, but fgx will go through g first, okay, become gx, And we'll go to another function f, and we get f g x. Oops, sorry. All right, like f g x. Okay, so these two are different. The process to go through first is different. Okay, this is f. Okay, I get an answer. A is 3 plus 7. Okay, how about B? B okay, are these two correct?
C is 22.
Yes, these two correct. So we'll look at this. A G f x. We'll look at fx first. 3x plus 2 G. Your function f x plus 2. Okay, so this 3x plus 2 will be your object for function g. So what is your function g? X plus 5 x. So this x and this will become 3x plus 2. Okay, and plus 5. So you get 3x plus 7. Okay, B f g x is we look at function g f x plus 5. X plus 5 is a new object for this function f. So 3x plus 5 plus 2. Okay, 3x plus 15 plus 2. Okay. Okay, next we look at these two. So your object is 5. So we just put the 5 inside here. AGF 5 is 22. Okay, like this. So they are different. So f which function come first, they will affect your composite function. So Must remember this. How about we look at these two? E, F. We map 5 into this function, we get 17. Oh. Then. Okay. Now we look at this. G. F5 we times with G5, 17 times 10, it is 170. So is it different? Still different than this. Okay, so this is, okay, so this and this, okay, they are the different. So these two are just multiplication of two function, but this is composite function, they are the different. Okay. Next. From here, fx is just, we go through the function twice. So okay, this f, and this is fx. Okay. X2 plus 14. Is this correct? Let's look at this. We'll do it now. Okay. So fx is this x squared plus 5, which is now became your new object for function g. So what is function g? 3x minus 1. And this will replace this in your function g. So 3 multiplied by x squared plus 5 minus 1. Okay. Okay, this is correct. So we'll look at fgx. Okay, look at this first. One that is closest to the object, which is g, function g. What is function g? 3x minus 1, 3x minus 1. Okay, so 3x minus 1 will be your new object in here, in your function f. So function f is x squared plus 5. Okay, so this object, we replace this 3x minus 1 square. Okay, we need to write the object inside the square because in fx, the x is squared. So we must write the O function g, the function g inside the square. Okay, plus 5. Okay. So what do we get? What do we get here? Okay, if you're not fast with your calculation, so you can write them out, or people with your calculation very fast, you can just straight to the answer. Okay, so multiply this. Sorry. 9x squared. Okay. The second one, minus 3x. Okay, how about the second? Minus 1 times 3x is still the same, minus 3x. And then minus 1 times minus 1, okay, which is plus 1. You get this. Okay, but this haven't not yet ended, so we only get for this part where we still have the plus 5. So 9x squared minus 6x plus 1. Okay, and this plus 5. So 9x squared minus 6x plus 6. Okay. And maybe we can try to factorize the final answer. Okay, factorize it. Maybe we can. What are the common factor? Okay, 3. So 3x squared minus 2x plus 2. Okay. Okay, this leaving at this part is the same as so leave at here also can, it's also okay. Okay. Next. For EFX. Oh, okay. This question actually there's quite some calculation. You need to power twice, right? So we look at fx. Okay, both are fx, function f. So we look at 1 first. So what is fx? X power 2 plus 5. Okay, so I see answer of this. Okay, we'll check whether this is the answer. Okay. X squared plus 5 is your new object for another function f. So in this function f, this object will sub in this x. So x plus 5, you'll need to square another time here. Okay, plus 5. Okay. So I'll skip this calculation. If you cannot get it, you can do it yourself. X4 plus 10x squared plus 25. And this plus 5. So which is this? Okay, so correct. Okay, okay, correct. Okay. Okay, next G. G will be GGX. Or we can write it as G where X is the same. This is the same. So we'll look at GX. 3x minus 1, and then another time 3x minus 1 minus 1. Okay, 9x, that 9x minus 4, yes. So this uses 6 will be your object of your composite function. So we'll look at this 4. It's very simple. What you need to do is you put this 6 into your composite function, which is this. Where's my FGX? This. Here. Here. Okay, here. And you substitute the 6 into here. So B, question B, the answer will be from here 6 power of 2, which is 36. So 3 times 36 plus 14, which is 72 plus 14. 86. Am I correct? Wait. 36. It's 3, sorry. Okay. Everyone makes mistake. So 3 times 36 plus 14. 108. It's just not times 2. So 1, 2, 2. Okay. Okay. How about D? 6 into here. Here. Okay, so this part is still the same, 108 minus 12 plus 2. So what we get here? 98. Right, 98. 3 times 98. Okay, which is 4. Right. Like that. I'm not making any mistake, right? 3, 6, 36. But if I make mistake, please correct me. Okay, how about this? 6 is the object for this composite function f(x). Okay, I'll erase some of it. Okay, f(x) is, so f, our object is 6. So this function will be 6 power of 4 plus 10 times 6 power of 2 plus 30. Okay. What is the answer of this? One six, yeah. 1, 2, 6. 6 power of 4 is 1296. How about here? 6 power of 2, 1686. Yeah, I got an answer of this. So let's see. This is 36. So times 10, 36 plus 30. 6. Yeah. Okay, this is correct. Okay, we'll look at the last. What is GGX? Is this. So if our object is 6, this x will be 6. 9 times 6 minus 4. 50. It is no need so much time. Okay. We have 2 more. Okay, we have 2 more. Okay, let's try this. GFX. Okay, we look at fx. G. What is fx? X plus 5. Okay, next g, our function g, which is square root of x. So g, and this is your new object. You just square root your object. Okay, it's placing x squared plus 5 in this x. Okay, in this x. Okay. What if our object is 16 in this composite function g of x? They will just put 16, plug 16 in here. Okay, since we know g of x is square root of x squared plus 5. If our object is now 16, g of 16 will be replacing this x and this x with 16. So square root of 16 square plus 5. 16 square, which is 256 plus 5. Okay, 261. Okay, you can leave the answer here if you want. Doesn't matter if you want to do it like 16 point, what is it this? 1, 1, 1, 6. Yeah, both is fine. Okay, since 261 is not a perfect square, so it's fine to just leave it here. Okay, both are accepted, but this is fine. Okay, next we look at fgx. Gx is square root of, so this is our new object, square root x. We plug this square root x into our function f. So square root x square plus 5. Okay, which is you cancel out this square and this square root. What you left is x plus 5. Okay, they are different. Need to repeat. They are different. Gfx and fgx. Everything different. They are not the same. So fg 16. Okay, you literally just plug 16 inside here. 16 plus 5, 21. So they are not the same. Okay, these two. Not the same. Okay. Next. E. Double f square x. What is fx? So this question is almost similar like the last exercise. So I'll go through it. Equal to another function f. So x squared plus 5 square plus 5. You get x power 4 plus 10x squared plus 25 plus 5. Okay, this is same as the last question. So f square 16. this is going to be a very large number. 16 power 4 plus 10 times 16 power 2 plus 30. Okay. 6, 8, 1, 2, 6. Is this correct? Okay, let me grab my calculator. 1 second. Six, 8, 1, 2, 6. So it's the same. So this is correct. Okay, next. G. G will be GGX or G square X. What is G? Function G is G square root X. So we so we map this object again using this G function G. So you'll get square root X. Okay, or you can write it as, since we know square root of X is equal to X power of 0.5. So double square root of X, you can write it as of 0.5, another 0.5. So you get X power 4, 1 over 4. Okay, we change object into 16. So 16 will be subs into this X. So 16 power of 1 over 4. So you get 2. Okay, it's the same as this. Is equal to square root 16, 4, and square root 4 is 2. So these two are the same. All right, last. Okay. This will be very simple. So I'll quickly go through also, since we don't have much time. GFX. Fx is square root of x. Gx is x squared. So if you look at this, they are the same, almost the same. This is square root, this is square. So at some point here, you'll see that they cancel out each other. So we'll look at this a first. Gfx, what is fx? Square root x. So g square root of x. Fx is square root of x. So square root of x will be object of your function g. Function g is this. Function g is x squared. So you substitute square root x into this x. It's square root x power of 2, which is cancel each other, you get x. So gfx is x. Okay, so in question B, gf3 is since here don't have any calculation, 3. Okay. How about C? F G X square root of 2. Okay, and this is square root of x. They cancel each other still. Okay, x. So it's also equal to 3. But they are the same, right? They are the same. Gfx is equal to fgx. This is only true in some case. Okay, not every case they are the same. Like the last question, we can see that gfx and fgx they are not the same. So this is just a coincidence that they get the same. So not all cases are the same. Okay, how about E? G square x. Gx is x square. So x square will be your new object in your x function g. So x square x power of 4. So g square power 3 will be 3 power of 4, which is what, 81, right? 339是81. How about we look at another one? G f square x. Okay, f square x. Oh, this is the okay, this is the same as this question. So maybe we just write it out. Square root. Okay, we put 3 into this composite function. Is equal to 3 power of 1 over 4. So you can leave your answer here. Or you write it as 1, 1, 3, 1, 6. Okay, they are the same. All right, we're done. So I'll quickly go through of what we learned today. So some question, is this true? Is fx multiplied by fx equal to f square x? Okay, we know that this is not true, right? Like I showed just now. I think where? Here, exercise 1. F5 times G5 is not equal to FG5. Here, FG5 is 32, and this is 170. Okay, so this is not equal. This about this FGX and GFX. So yeah, they are also not equal. Right? also not equal. So how about this? This f square x. Can you fx multiplied by fx is fx square, right? Is this equal to this f square x? We'll look at example from here. Fx is this square root x. Square root x, if we multiply fx twice, we get square root x times square root x times square root x. What you get from this? So you get x, right? Okay, since x is equal to x 1 over 2 plus 1 over 2. So x1, which is x. How about this composite function? Look at this. F square root x. Another time square root x. So this, they are also not the same. So f square x is not equal to fx times fx. Okay, this will be the end of our class. So before I end this class, hey, your favorite part, okay, homework. Okay, I'll need. Oh, sorry, my cat is disturbing me. Sorry. I'll need you guys to split into a group of. Wait, guys. Group of 5. Okay, you can form a group yourself. Okay, and you'll do complete these 2 homework, and then you'll need to take photo and send to me like tomorrow or maybe day after tomorrow. So they are the same as what I taught just now. So this is the first question, and this is the second question. Hey, don't worry, the class is recorded, so you can look, you can check it back if you miss the question. Is there any question before I end this class?
No questions.
Okay. So have a nice day and good night. Bye bye.